just so you know that kind of those are those are two. No, that was evidence of the okay. This will actually be a little easier than what you've already done because it involves calculating. So here we go. Now, if you remember DeMoivre's theorem, you do.
Oh wait, we need to get it in CIS.
Yes, you have to get it in polar form first. So write that down first. Polar, put in polar. And let's talk a little vocabulary real quick, because I know there's at least one person there, I'm sure, when I say put in polar, that means nothing. So, in terms of, if I have 6 plus 4i, that's rectangular. If I convert that to r cosine I sine theta, that's polar. So when I say put it in polar, that means you need to convert it to that cosine I sine theta. Follow? Yeah. All right, so cool. Let's draw, shall we? 6, what does that tell me to do? Right 6. And 4? Up 4. So I'm in the first quadrant. And how do I find the r? My Pythagorean theorem. So r is the square root of 36 plus 16. So I think you'll agree that r is the square root of 52. Okay? Try that in your calculator. This over a little bit. Square root of 52. I'll do more with that later. 7.211. You follow? Okay. So I have 7.211 cosine I sine, and how do we find the theta? Inverse tangent. Sometimes do I have to do more than inverse tangent, like add to 180 or subtract from 360? Yeah, depending on the quadrant. But in this case, do you agree it's just inverse tangent? Inverse tangent of what? 4 over 6 or 6 over 4? Or does it matters greatly. And it is 4 over 6. Why 4 over 6? Opposite over adjacent. Throw that into your calculator. Inverse tangent of 4 over 6 is, I'm in radians. Okay, so I'm going to try that again. Did you get 33.690? Okay, cool. All right, so the problem is now 7.211, 33 point, what did I say, 690? Okay, cool. Now, am I done? Is that my answer? No. All right, so what now do I have to do? Yeah, to the 1/4. That's where we actually use DeMoivre's theorem. DeMoivre's theorem is what do you do when you get it converted to polar to an exponent? All right, so what do I do with the 7.211? Do I multiply it by 4, divide it by 4, take it to the 4, take it to the 4th? Take it to the 4th, all right? So I'm going to take that to the 4th, and the angle, do I multiply it by 4, divide it by 4, take it to the 4th? Divide by 4. Divide by 4. 33.690 divided by 4. And so when I do that, if you just scroll up to that 7.211 and grab it, but now take it to the 1/4. I guess you could also root it to the 1 divided by, oh shucks. Oh, what? 1 divided by 4. Did you get 1.6387? So I will take 1.638, which is truncated, or 1.639, which is rounded. 1.639 cosine I sine. Same goes with the angle. Go up to the angle you found, grab it, but now we're going to do what to it? Divide by 4, 8.4225. So would I take 8.422? Yes. Would I take 8.423? Yes. Is there 1? And that's degrees. Okay. Am I done?
No.
Why? What else do I have to do? Okay, so remember, when it's roots, there are multiple answers. When it's a whole number power, like to the third power, that's just a one answer case. But this is a root. It says right in the problem there's 4 answers, yeah? So how do I find the spacing for the others? Do you always divide by 4, or it's 4 in this case? 360 divided by the root, in which case this is 4, so it's 90 degrees apart. So what are my other 3 solutions? 98.423 degrees and 188.423 degrees and 278.423 degrees. I have 1, 2, 3, and my original solution 4. The answers, now I was taught, you're going to love this, but the book I learned from, that my teacher said, if you're given rectangular, then you answer rectangular, which actually would make for a lot more work, because then you have to convert that to rectangular. Saxon, for whatever reason, answers in colors, so you are okay. Let's try another one, a little more you and a little less me, although you did pretty well, I got to say. So what do you do first? Go to polar. Okay, I need to find what this is in cosine I sine form. You must go to polar. You must. Okay. What is this? Your group is up here. All right. What quadrant do I end in? Second. Left 17 up 14. Or, sorry, left 17. Yeah, left 17 up 14. So, R. Find it and shout it out. First one to shout it out is awesome.
22.8.
Oh my gosh. You're so quick. Plus 14 squared. 22.022. 4023 is also fine. Really cool? Okay. 22.023. That comes from 17 squared plus 14 squared. Theta. What kind of 2 steps am I going to need to do for theta? Actually, I'm going to call that alpha, and this is theta. Say it again. Inverse tangent. 14 over 17. Do I use the negative or no?
No.
Do not use the negative. And then what else? 180 minus. 180 minus inverse tangent of 14 over 17. Oops. Minus inverse tangent 14 divided by 17. Did you get 140.527, and does that make sense? Okay. So 140.527. All right, cool. Now, in terms of what to do and how to communicate, you need to communicate your DeMoivre, so take that 22.023 and explain to the person or show to the person what you're going to do with it. What are you going to do with it? Take it to the 1/5 and the angle. Explain or show to the person what you're going to do with it. Divide it by 5. Okay. Do that by recalling an answer. Do not use rounded numbers. Recall the answer and then support 1.8559. And the angle, somebody have 140 divided by 5, what is that? Probably 528-ish? What is it? Divided by 5. 28.1055. Do we all agree? Everybody doing okay?
Yes.
Okay, 28.055 degrees. And then, is it one answer or multiple answers? When do you get multiple answers? When it's a root. Okay, so it's a root, so we have 5 answers. What's the spacing? 72. 360 divided equally among 5 answers is 72 degrees apart. So our other answers are 1.8559, or 5, I'm giving 4, I don't know why. 855 or 856, whatever you prefer. Cosine sine, what is that, 90, 100? 100.055 degrees. Add 72 again. 172.055. Wait. 855 again. What's 172 plus 72? 244.055 degrees. And add 72 again. 316.055. What if you kept adding 72? Yeah, you get a 70, if you add 72 again, you get something that's actually the same as 28. You'd start hitting those same 5 angles again. 360 different. So there's your answers, and you're good. Are you with me, people? You're so smart. Try the next one without a calculator now. How many answers will you get right off the bat? One answer, not 6. One answer. What quadrant? 4, I agree. If it's no calculator, it must be a reference kind of triangle. What is the R? 2. And what is the angle? Is that a 45, 45, 90 or a 30, 60, 90 if you see root 3 in there? It's a 30, 60, 90. Now the question is it 30 or not, or 60? It is 60. If you draw it big so root 3 is longer, then it's surely 60. All right, cool. So now we're ready to do DeMoivre's theorem, which is what you do once it's in polar. What is 2 to the 6th? The same as 4 to the 3rd. What is it? 64. Yeah, 64. And cosine I sine 360. So I guess I would take 64 cosine I sine 0. So you're saying it's not 60.
Because it's in the 4th quadrant.
So would you agree with negative?
Yeah.
Yeah, but that's not how we do stuff. You're right. So 300. I'm sorry. You're absolutely right. I'm a little rusty myself. Good job. So 300, yes? And 300 times 6 is 1800, and 1800 is how many 360s? An even number of 360s? Seems like it's 5 equal 360s, isn't it?
Yeah.
Would you? I agree. So this is 64 cosine I sine 0. What would that be in rectangular if you were so inclined? 64, yes. All right, that is good stuff. You guys are darn good. Let's do 1 or 2 off the homework, and then I want to review a little bit of polar action. Did you have a delightful break?
Yes.
everything, got a couple, and then we're gonna take a quick break. Don't you use you have your hair front and down? Do you want to tuck from his ear?
When I'm working,
Oh, I don't want it in your face.
I'll have the
I like it.
There's a quiz.
I like it.
There's a quiz night.
There's not a quiz tomorrow.
Oh, for different.
Oh. All right. Would you start with 6 and 7, please? Yes, you're on page 552. Fourth roots of 3 plus 4i. That's 6. 7 is 3/3 roots of 2 plus 3i.
Yeah. And why does it not remember it? It's not numbered left. It doesn't matter. It does have a number. It's 70 and class 3. Day 2. It's got 2 talking, but it's not graded.
I can't hear you. What?
It's apparently not.
Alright, here we go.
Does anybody have ethics? Yes. Yeah. Six. Make it. Yeah. Jill, wait, you're in it. You're I cheated in it. So we're good.
I apologize.
Wait, make it fine.
Now just throw it.
I have so many classes with I have to talk to
Which is, physics.
So probably good. He's like the one who does it. Overall.
Becomes
Wait, Megan, did you get put in ethics? What do you mean? What teach what did you have lessons? I had PE, but that was fair. And then you know how you submitted Josh, that was up. But I didn't see so now I have no, it does. No, I lost the last one. And you can find, I actually gave you class and I barely thought of you. But, no, I never transferred. Yeah.
Hello.
but not 100%. That's
I don't know why it's really easy. I don't know. Because I think that's if you go to polar, then
Yeah, but that's not what this.
I mean, go to rectangle.
Yeah.
and you have to polar.
You have this one.
Oh, okay, thank you.
So, Cole's moving from AB.
Yeah.
Okay. I know, I get it. I get that much right now. Thank you.
All right. Please do communicate your work like we did in the notes. I don't want just an answer. All right. Somebody want to share their answer? Or should I just call them? Not there yet on the first one? On
Oh,
six?
on the first one.
Hey, hit me. Megan, what's your answer for the first? Just give me your first answer you got.
Oh, 1.495 cosine I sine 13.283.
I love it. Perfect. And I love that you said cosine I sine. Yeah. So how far spacing between the two answers? Okay. What's the spacing between the answers? 90. Yes, indeed. So you should have had other angles of maybe 103-ish, 193-ish, and 283-ish, yeah. So you should have 4 answers circled because it's a 4 feet. All right, 7.
It's a long time.
I don't know where to start.
No, not all of us have that interesting lives.
And you saying in this back, very interesting.
And you just said you agree with that.
I do agree.
So, can you add yourself?
I'm still kind of. It's only happened like 7 times last year.
Only seven.
Only 7.
That's really nothing.
It's like only 7. 7? Yeah, kind of less than.
You just need to get it.
About on 7, are you done there? All right. Let's get the hard ones done. All right, are you ready to talk about 7? Okay, what'd you get for an answer? Allie?
Huh? I wrote in the wrong box.
That's okay.
I'm already starting off wrong.
You're good. Just draw your own. It's fine. Go ahead, what's your answer?
Me or Kate?
Oh, no, Allie.
Ah,
Well, I did it 4-3 the first time, so I only have the first one. But
Okay, then help her out.
1.533 cosine sine 18.76.
Love it. What was your spacing between to get to the other two angles? 120. Okay, so you should have 138-ish and 258-ish for the other two angles, right? Okay, would you jump to number 1? I want to make sure that you remember probability either or. It said there are 90 people in the room. Half were girls, 1/3 were redheads. Half girls, 1/3 redheads. And it said the 2/3 were either redhead or girls. Or girl. They say, what's the probability of choosing a redheaded girl? Redhead and girl. What's the symbol for and again? Like that, yeah. Girl. Gosh, this is kind of a weird question. Don't they usually ask you for the probability of or, not the probability of and? What should we do? Let's write the formula like we normally would and put stuff in, and then we'll work about that. So what's the normal probability idea? Probability of redhead or girl, which that you could say is this, yeah? How do you usually find probability of or? Probability of redhead plus probability of girl minus, and that minus is so we don't double count. We talked about redhead, we talked about girl, and now we've double counted redhead and girl, so we need to subtract away probability of redhead and girl, yeah? All right, that's cool. Let's just substitute in. What's the probability of redhead or girl? 2/3. They give you this, actually. They're giving you the final answer, and they're asking for one of the parts. What's the probability of redhead? 1/3. What's the probability of girl? 1/2. And that leaves us probability of redhead and girl. So, you just have to do a little bit of arithmetic. I hope you can still add and subtract fractions. If you can't, please keep it to yourself. That'll make you cry. What do you get? 1/6. Oops. 1/6 is true. Good. All right. Would you jump to this one? I want to take a break for. Let's warm up with the easy ones. All right. So would you go to box 9? A is to sketch in the first half of the back book. Sketch secant. And in the right half of the box graph, or sketch cosecant. Remember how to graph secant? All righty then. First, put a graph down. That'll be good. Oh, maybe we should just do first, or the right side. What do you think? Yeah, that's fine. Okay. So, what does secant relate to? Cosine. So, let's draw a cosine curve. Cosine curve looks like that, yeah? And it ends at, what's a normal period? 2 pi. So it would go pi over 2 to the center line. Pi would be at a minimum. 3 pi over 2 would be at a center line again. And 2 pi is back to the max, yeah? Okay. Now, and then obviously we could do the right side as well if we wanted to. What about secant then? What do we do? where cosine is 0, secant is 1 over 0, and therefore undefined. So we have asymptotes where it crosses the center line, yeah? So at every odd pi over 2, we're going to have asymptotes. Cool. And then what about the actual secant curves? What do they look like? Little U's. And how do you decide where to draw them? U's and N's, really. Yeah, they need to touch the peaks and valleys of the cosine curve, so you should look like that. Is that coming back to you? Okay, cool. Now do cosecant rather. Cosine curve shouldn't really be solid. It's just kind of graph A, but it's not the actual cos. Where is one of your asymptotes? 0. There's an asymptote 0. True. What else? Yep. Okay. Where is give me the coordinates of a local minimum. Let's get some calculus talking. Give me the coordinates of a local minimum.
Negative pi over 2,
Negative pi over 2, negative 1. Is that a local minimum or a local maximum? It is not a minimum. It is a maximum. And that's because that y value is greater than the ones in its neighborhood. Okay? This is a local minimum because it's less than all the ones in its neighborhood. Is it an absolute minimum? No, it is not. Okay, I would not say it's an absolute minimum because there are points higher than that, or lower than that. Okay?
Of course.
All right, now, that said, let's pause because I'm worried that you're not going to be able to do the ones that we have, which we know are much harder than the books ones. So let's pause and do a little review of harder trig graphing. What do you say? What do you say? So you're prepared for the worst case scenario. Not amateur hours. How are you doing? How did you get your one?
This is how I earned my cups. I earned cups. Those are very,
All righty. Okay, yes, I know it's been a while, but these are on the first test, and not to mention they're more likely what we're going to use when we go to modeling and good stuff. So, let's do a couple together. We'll do 2 together and 2 on your own, all right? Tangent, what does the base graph of tangent look like?
goes through 0.
Goes through 0. So it looks like, remember, tangent is sine over cosine. So it goes through 0. It has asymptotes where cosine is 0. So what are the asymptotes on tangent? At pi over 2. And such, yeah? And negative pi over 2. And the graph goes through the origin and bends up to the right. Okay? So it has asymptotes where cosine is 0. Cotangent is cosine over sine, so it has asymptotes where sine is 0. Where is sine 0? Sine is 0 at 0 and 180 or pi, yeah? And what does the cotangent graph look like? It looks reversed. Okay, so they're different in 2 ways. First of all, they bend differently, and second of all, their asymptotes are different because they have different zeros in the denominator situation. All right, so let's do one together, shall we? For number 1, we're looking for graphs that go this way. And instead of having an asymptote at 0, this is going to be shifted how? Right pi over 2. So instead of an asymptote at 0, I want an asymptote at pi over 2, and it bending to the up to the left. So what do you think?
B.
B. It is B. Here it has an asymptote at pi over 2, and that has the cotangent bend, right? So it is B. Let's jump to 3 to do a tangent one. First of all, if tangent normally looks like this, then what will negative tangent look like? Negative tangent will look like cotangent. So I'm actually looking for one that looks like that, but it's shifted how? Right pi over 4. Now, that means if the asymptote, if it normally goes through 0, then now it should go through pi over 4, yeah? So which one goes through pi over 4? D. Yeah, and it has a reflected tangent shape, so it's D. Follow? All right, try 2 and 4. Asymptote at negative pi over 4. What'd you say for 2? I agree. And then by default, okay. Those are much harder than number 10. So going back to the homework, number 10 you can put an X through that. We did much more work for number 10. So you don't skip 10 on the homework. You're welcome. All right. Hi. Yes. All right, so